Let us look at the problems where we can apply trigonometry. Here is one problem. A person is standing at a distance of 80 meters from church looking at its top. The angle of elevation is 45 degree. Find the height of the church. Now for application of trigonometry type problems, it is very much important you visualize the problem. Once you visualize the problem, it is very easy to solve this problem. To make sure that you develop a habit of visualization, we are showing you here. Let's say this is our church and this is a point where person is standing. This line marks the height of the church. This line marks the distance of a person from a church. We have taken center of a church, as center of a church is the most heighted point. And this lines indicate person is watching at the top of the church with angle of elevation. Let's call that angle of elevation theta. Now here you can see a right angle triangle with angle theta. So right angle triangle, and finding out the measurement is nothing but application of trigonometry. Let us look at the given data. We have theta is equal to 45 degrees, which is nothing but angle of elevation. We also have distance of a person from church, which is 80 meters. This is that distance. And we need to find height of the church using these two datas. If we look at this properly, what is distance of a person from a church? It is adjacent side to angle theta. And height of the church, it is opposite side of angle theta. So give it a thought, which is the trigonometric ratio which deals about opposite side and adjacent side? Yes, tan theta is equal to opposite side upon adjacent side. In this, we have value of theta, we have value of adjacent side. So we can find out value of opposite side. So tan 45 is equal to opposite side upon 80 meters. Are you getting this? Adjacent side is 80 meters. Tan theta is nothing but 45. So we apply tan 45 degrees is equal to opposite side upon 80 meters. Now we have already learned tan 45 degrees is equal to 1. If you want to understand how this has come, tan 45 is equal to 1, watch our previous videos on trigonometric ratios for different angles like sine 30, sine 0, tan 45, etc. So replacing value of tan 45 as 1 into the above equation, we get 1 is equal to opposite side upon 80 meters. To solve this, we have sent 80 meters to left hand side. As it is going to LHS, it will go in numerator. We get 80 meters into 1 is equal to opposite side. So opposite side is equal to 80 meters. But what is opposite side? It is nothing but height of the church. So height of the church is 80 meters. Wasn't it easy? Let us solve the next problem. From the top of a lighthouse, an observer looking at a ship makes an angle of depression of 60 degree. If the height of lighthouse is 90 meter, then find how far is the ship from the lighthouse. Let's visualize the problem first. Here you can see a lighthouse and a ship at a distance. Now an observer is watching the ship with an angle of depression. So angle of depression is with horizontal. Theta is equal to 60 degrees. This is the height of the lighthouse, 90 meters. Let's call this triangle ABC. So we have given data, angle of depression is equal to 60 degree. As angle of depression is equal to 60 degrees, these two lines are parallel lines to each other. So angles opposite to each other are similar. That's why this angle C will also be 60 degrees. Let's call it also theta 60 degrees. Side AB is height of the lighthouse. AB is height of the lighthouse, 90 meters. And we need to find distance BC, distance of a ship from the lighthouse. We can use tan theta, which is opposite side upon adjacent side. So we have to use tan theta and tan 60, because theta is 60, tan 60 value is square root of 3. Pause the video here and try to solve further on your own. Otherwise, answer would be given. If you were able to solve, very good. If not, pay attention. Tan 60 is equal to AB upon BC. That means opposite side upon adjacent side. We know tan 60 value is square root of 3 and AB is 90. Replacing this value, we get square root of 3 is equal to 90 upon BC. Rearranging the term, sending BC to LHS and square root of 3 to RHS, we get BC is equal to 90 upon square root 3. Now square root 3 is equal to 1.73. Many times this value would be given in problems. So BC is equal to 90 upon 1.73. After doing the calculation, we get BC is equal to 51.9 meters, which is distance of a ship from a lighthouse. Let us solve one interesting problem now. Problem is, two buildings are facing each other on a road of width 12 meter. From the top of the first building, which is 10 meter high, an angle of elevation is found to be 60 degree. What is the height of the second building? Let's visualize first. Here are our two buildings. These two buildings are separated by a road which has a 12 meter distance. We already know one building is having a height of 10 meter and observer is on top of that building who is making an angle of 60 degree to the top of second building. So we know that second building height will be 10 meter plus something. So what is the given data? Theta as 60 degree, that is nothing but angle of elevation 60 degree. Height of building A is 10 meters. So now if this is 10 meters, that means we know the height of building B is also 10 meter plus something. The distance between two buildings is 12 meters. So same distance would be here, as this is forming a rectangle. So same side measurements. From this, height of the building B would be 10 plus something. Let's call it as 10 plus x. Now the distance between two buildings, what it is? It is adjacent side of angle theta, which we know 12 meters. And what is x? X is opposite side of angle theta. I'm sure you must have guessed that we would be using tan theta. Tan theta is equal to opposite side upon adjacent side. Tan 60 is equal to x upon 12. Tan 60 value is root 3. Replacing this value over here, we get square root 3 is equal to x upon 12. Sending 12 to LHS, we get 12 square root 3 is equal to x. We have already seen height of building B is 10 plus x. Now we have found out x. Height of building B is 10 plus 12 root 3. Let's move on to the next. Two poles of height 18 meters and 7 meters are erected on ground. The length of a wire fastened at their top is 22 meters. Find the angle made by wire with the horizontal. Let's visualize this first. Here are our two poles. One is 18 meter high, another is 7 meter high, and there is a rope which is tied at the top which is 22 meter in length. Let's convert this into a right angle triangle. So this is the horizontal distance between the pole, and this is the vertical distance, and this is the vertical distance. So this forms a right angle triangle. This is the horizontal distance, and this is the vertical distance of second pole above pole 1, which forms a right angle triangle. And this is horizontal. So we have to find angle made by wire with horizontal. This angle they have asked us to find this angle. I'm summarizing it again. We have pole 1 7 meter high. We have pole 2 18 meter high. We have wire 22 meter in length tied at the top of both poles, and we have been asked to find the angle made with the horizontal. Let's call this as angle theta. These are parallel lines. So this angle and this angle would be similar as they are opposite angle. So if we find this angle, we will be able to find this angle theta. So given data, pole 1 height 7 meters, pole 2 height 18 meters. From this data, we know pole 2 height above pole 1 is 11 meters. How did we find this? We already know pole 1 height, which is 7 meters. So pole 2 would be 7 meter high up to this point. The total height of pole 2 is 18 meters. 18 minus 7, 11 meters. So pole 2 height above pole 1 is 11 meters. So we get one side of this right angle triangle. We already have hypotenuse 22 meters. I'm sure now you are getting some hint how to solve this problem. And we need to find angle theta, which is angle made by wire with horizontal. I have already shown you angle made by wire with horizontal. This angle theta is nothing but angle made by wire tied at top of small pole and top of tall pole, this angle, right? So if we find this angle, then our problem would be solved. So in terms of trigonometry, what we have? We have opposite side of angle theta, 11 meters, and we have hypotenuse, 22 meters. So which trigonometric ratio you would use? That's correct, sine theta, opposite side upon hypotenuse, which is nothing but height difference in poles upon wire length. Height difference between poles upon wire length. So sine theta is equal to 11 upon 22. Height difference is 11, wire length is 22. So sine theta is 1 upon 2. Now ask yourself, which angle sine value is 1 upon 2? Yes, that's correct. Sine 30 is 1 upon 2. So what is theta? Theta would be 30 degrees. Hence, angle made by wire with horizontal would be 30 degrees. Did you get this? Let's solve the next problem. A storm broke a tree and the top of tree rested 20 meters from the base of the tree, making an angle of 60 degrees with horizontal. Find the height of the tree. As usual, let's visualize it first. Let's say this is the tree. During the storm, it cut from a certain point and it fell on a ground like this, making an angle with the horizontal. Let's convert this into a triangle. Let us say BD was the original height of the tree. It cut from a point A and it fell on a ground, making an angle theta with the horizontal. BC is the distance where tree rested from its base, which is already given, and AC is the distance of the cut portion of the tree. AB is the standing portion of the tree. What we have been given is angle made by cut tree with horizontal is 60 degree and length BC 20 meters. So this becomes our given data. Theta is equal to 60 degree and BC is equal to 20 meters. We need to find length AB, the portion of tree still standing, and length AC, the portion of a tree which is cut. And if we add length AB and AC, that means this length and this length, we will come to know the original height of the tree, which is length BD. In terms of trigonometry, we have theta and adjacent side, and we need to find opposite side. So which trigonometric ratio you would use? That's correct, tan theta, opposite side upon adjacent side. That is equal to AB upon BC. Tan 60 is equal to AB upon 20. We already know tan 60 is equal to square root 3. Let's replace this value. We get square root 3 is equal to AB upon 20. To solve, we send 20 to LHS. We get AB is equal to 20 square root 3 meters. So we found out the length AB. That means portion of tree which is still standing on ground. Now we need to find length AC, which is hypotenuse. Here we can use sine theta because we already have now AB, which is opposite side. Sine theta is equal to opposite side upon hypotenuse, that is AB upon AC. Sine 60 is equal to 20 square root 3 upon AC. We have just found out the AB length, which is 20 square root 3. We have used the same. So sine 60 is equal to 20 square root 3 upon AC. Sine 60 value is square root 3 upon 2. Let's replace. We get square root 3 upon 2 is equal to 20 square root 3 upon AC. Sending AC to LHS, which goes into numerator, and bringing square root 3 upon 2 to RHS, we get 20 square root 3 into 2 upon square root 3. Square root 3 upon 2 becomes inverted when it goes to right hand side. So we get 2 upon square root 3. Square root 3 upon square root 3 is equal to 1. So remaining is 20 into 2, that is equal to 40. And this is 40 meter length. We have already found out length AB, which is 20 square root 3. We have also found out length AC, which is 40 meter. And here we have already seen length BD is equal to length AB plus AC. 20 square root 3 plus 40 is nothing but total height of the tree. Let's solve the next problem. A kite is flying at a height of 60 meters above ground. The string attached to the kite is tied at a ground. It makes an angle of 60 degrees with the ground. Assuming that string is straight, find the length of the string. What I am going to do is I am going to help you visualize this problem but afterwards pause the video and solve the problem on your own. So this is our kite which is flying 60 meters above ground. This is a vertical distance given. So this is a ground level. Kite is flying 60 meters above the ground. And this is the string of the kite which is tied to the ground, which makes an angle theta with the horizontal. That angle is also given 60 degrees. Given data is theta 60 degrees, height of the kite above ground 60 meters. We need to find length of the string. We have opposite side. We have angle theta. We need to find hypotenuse. Pause this video, solve this problem on your own. Answer would be provided, but I highly recommend try and solve this problem on your own. Let us solve an interesting problem. A ladder on a platform of a fire brigade van can be elevated at an angle of 70 degree to the maximum. The length of the ladder can be extended up to 20 meter. If the platform is 2 meter above the ground, find the maximum height from the ground up to which the ladder can reach. We have to visualize this to solve it correctly. So this is a fire brigade vehicle. The ladder on top of the vehicle can be elevated at an angle. Angle is given as 70 degree. And the length, maximum length, ladder can be extended is up to 20 meter. And the height of the fire brigade vehicle is 2 meter. And the angle with which ladder can be extended is 70 degree. Let's call it theta. Let's convert this into a right angle triangle. So this is the right angle triangle in which hypotenuse is 20, theta is 70. We need to calculate the opposite side, and we have been given a data of vehicle from ground is 2 meters. So the total length of the ladder would be 2 meters plus opposite side. So given data theta is equal to 70 degrees. Let's name this triangle as ABC. So we have been given AC, that is hypotenuse 20 meters. We also have height of a vehicle, that is 2 meters. And we need to find length AB, which is opposite side, and maximum height ladder can reach from ground, which is nothing but AB plus 2 meters. AB plus 2 meters. So we have theta and hypotenuse. We need to find out the opposite side. Which trigonometric ratios you would use? Yes, sine theta, which is nothing but opposite side upon hypotenuse. In case of this triangle, it would be AB, opposite side, upon hypotenuse AC. Sine 70 value is 0.94. Don't worry, such kind of odd sine angle values would be given in problem itself. So substituting sine 70 and AC value, we get sine 70 replacing by 0.94 is equal to AB upon AC value replacing by 20, which is already given. Simplifying this, sending 20 to LHS, which goes into numerator, we get 20 into 0.94 is equal to AB. By doing this multiplication, we get value of AB as 18.80. We have already seen maximum height ladder can reach is AB plus 2. Now we have AB, which is 18.80 plus 2. So maximum distance a ladder can reach is 20.80 meters. Let's solve an interesting problem. While landing at an airport, a pilot made an angle of depression of 20 degrees. An average speed of pilot was 200 km per hour. The plane reached the ground after 54 seconds. Find the height at which plane was when it started landing. We have been given sine 20 value of 0.342. Let's visualize this first. Here is our plane. Here is the airport. Plane started a descent, and that's why it made an angle of depression of 20 degree. Let's call it as theta. Now since these two are parallel lines, these are opposite angles, so angle C also would be theta 20 degrees. This is a particular problem where we don't have any side measurements given. What data we have been given? Theta is equal to 20, speed of an airplane, which is 20 km per hour, and time to land, which is 54 seconds. Let's see how we can calculate the distance using speed and time. Distance is equal to speed into time. We have speed, we have time. Distance is equal to 200 km per hour into time. We do have time, but we will put the time later. Let's first simplify 200 km per hour because the time is given in seconds. So let's convert this kilometer per hour into meter per second. 1 kilometer is equal to 1000 meter. So we can multiply 200 by 1000 to get the distance in meters. 1 hour is equal to 3600 seconds. That means 60 minutes into 60 seconds. So 3600 seconds. We have to divide 200 by 3600 seconds. Let's do that. We get distance is equal to 200 into 1000 divided by 3600 into 54 seconds as it is. Cancelling these two zeros from numerator and denominator, we get 2 into 1000 upon 36 into 54. Simplifying it further, 2 ones are 2, 18 twos are 36, so we get 1 upon 18 into 1000 into 54, which is nothing but 1000 into 54 upon 18. Simplifying it further, 18 ones are 18, 18 threes are 54. 1000 into 3 divided by 1, which is nothing but 3 into 1000, which is 3000. Now this 3000 meter is the distance of AC. We have calculated now one side measurements. We already have angle. Now we have AC, which is hypotenuse. We already have theta 20 degrees. We need to calculate AB, height or opposite side of theta. Here we have to use sine theta, which is nothing but opposite side upon hypotenuse. Opposite side is AB, hypotenuse is AC. Replacing the values, theta is 20, so sine 20 is equal to AB upon AC. AC is 3000. We have already been given sine 20 value as 0.342. Replacing that value, we get 0.342 is equal to AB upon 3000. Simplifying it further, we get 3000 into 0.342 is equal to AB. Doing this multiplication, we get AB is equal to 1026 meter. We already know 1 kilometer is equal to 1000 meters. So AB is equal to 1.026 kilometer, which is height of a plane from a ground. When it started its descent,